Okay, so this is gonna be your construction activity, and this is the last time I'm going to carry out these constructions for you, because you just need to revisit lesson 1A, B, C, D, and E in order to learn how to do these constructions. So, for the first one, construct an equilateral triangle inscribed inside a circle. All you have to do is draw a segment from the center to anywhere on the circle. Now you take the compass and open it to the length of the radius. At least you should know that much. Right here, length of the radius. So now you go to this point on the compass and draw. See that? In other words, you're drawing a circle, but you don't have to. So you go here, then you go to the next point of intersection and you label it. You go to the next point of intersection, see that, and you label it. You go to the next point of intersection, you label it. Next point of intersection, you label it. And finally, you have this right here. Okay? Now all you gotta do is connect every other point of intersection. So I'm gonna connect this point with this, and I'm gonna skip this one. I'm gonna connect it here, and then I'm gonna connect this point with this, and that's your equilateral triangle. Okay, so the next, you see the construction marks should be right there. All right. The next thing, it says find the perpendicular bisector of each side of triangle ABC. Okay, so that's exactly what I'm gonna do. I'm gonna construct the perpendicular bisector. Perpendicular bisector means open more than halfway the length of the segment, this more than halfway, and string a circle or just an arc. Go to the other side. Okay, we're talking about BC. I'm doing BC right now. So you go here and do that. Now you construct a line long enough. That is your perpendicular bisector. Okay, and that was BC. So the idea is that you take notes of what you're doing. I did BC so you don't get confused later on. Now I'm gonna do AC. So I go to A and I open more than halfway the length of the segment, and I go like this. See, draw an arc or a circle or a semicircle, and then I'm going to C because that's what I'm doing, AC. I go here and I draw another arc. So now the points of intersection are right here, this one and this one. If you're not sure, just look for the points where the line that you're going to trace looks perpendicular. So you have that now. This line is perpendicular to what? To AC. So that's what I just did. AC. Look, AC. And now I just need AB. Well, take the compass, open more than halfway, or to the length of AB. Okay, if you want to do a circle, really doesn't matter. So look, I'm just gonna open more than halfway right here. So I go here and I extend the circle so I know which segment is the one that I drew. Sorry, which arc is the one that I drew. So I know it's this one. I'm doing AB, right? And I do the same thing here. Now I know which 2 points are the intersection. I'm talking about this point right here and this point right here. Now all I gotta do now is connect the points. Let me see. Okay, I'm gonna do it with this one. Guess what? All 3 perpendicular bisectors intersect right here. In this case, I'm not asking you to find the circumcenter, but if I was, then you would label this point circumcenter so you don't lose points. So that's it. The last segment I did was AB. Look, all 3 segments have their perpendicular bisectors, and that's it. You're done. Perpendicular bisector is not that difficult. All right, let's move on. Okay, it says find the angle bisectors. Okay, let me just make sure that I focus this thing. Okay, very good. It says find the angle bisector of every angle. So you're gonna do the same thing, repeat the same process to every angle. So what you do is you put the compass on point B, you trace an arc. Then you open the compass to the length of the intersection right here. See that? To the intersection right there. And you trace another arc. You go to the other intersection and you trace the following arc. Now listen to me very careful. If you're not sure, you gotta label the point of intersection, okay? See, since this is triangle ABC, let's call this point DE. So then you say, okay, so now I'm gonna draw with the length of here. Okay, that's the radius. I'm gonna draw a circle D. Then I'm gonna draw a circle E, and that's the point of intersection. What do? You go from the vertex and you draw your ray. That's the angle bisector. Then you gotta do it to every other angle, to angle C and angle A. I don't understand how difficult this is. Look, let me do angle C. Draw the arc, okay? Let's call it FG. Okay, the points of intersection, since I already have DE. And now open the compass to the length of this, to the length of the new segment, to the length of the points of intersection. And now just draw two intersection lines. My intersection lines don't look crooked, neither should yours. So now you go from the vertex and you trace a ray, okay? And now I gotta do it to angle A. So you draw an arc, okay? And you gotta make sure which arc you're drawing. You draw an arc. Now this is the point of intersection, not this one. This one right here is the point of intersection, not this one. So I label the point of intersection right here. Okay? You could call it something else. I call it HI. HI if you want to. The idea is to know what you're doing. Open the compass to the length of the new arc. Okay? And draw a bigger arc so you know which one is which. So this is my arc right here, and this is my arc right here. Now you know which one is the intersection right here. And now look, this is where all the angle bisectors intersect. I'm not asking you to find the in center, but if I was, you would label this in center. Okay, with angle bisectors. Right then. The next one says find the altitude from angle A. This is angle A. To find the altitude is like drawing a perpendicular from a point. Look, the most important thing is that you need a segment. So you need to create a circle or a semicircle or an arc or two marks on this opposite side. Let me see, right here it won't do it. Let me try smaller. Let me see. Smaller, maybe I could do smaller. Okay, look, it doesn't go, it won't intersect it twice. Here it will intersect it twice, but you know what? Who cares? I'm gonna draw a segment that is long enough. Okay, funny thing, okay, this is not what I have intended. Funny thing, it actually intersects it. I was hoping that to go over and then I have to extend the line, but it's okay. No, it does it right here. Okay, this is your new segment. Okay, so now I think this or a little more over here, but that's it. Now you have your segment. Now draw the perpendicular bisector from these two segments. Look, open more than halfway and do this. Open more than halfway, do this. Now you connect the points from the vertex right here, and look, it lines up. Why didn't I go all the way down? Yes, I can go all the way down, but I don't need to. I just need the altitude. And altitude goes from the vertex and is perpendicular to the opposite side. That's it. Okay? It says, draw a circle of any radius and inscribe a square in it. Okay. So draw a circle of any center. So let me have my center over here. So you put the compass here and you draw a circle. See that? Now from the center, draw a diameter. It could be here, here. A diameter is a chord that goes from the center. So I'm just gonna do it right here. Oh, you see that? You could have done it like this, straight. I don't care. It's still gonna work anyways. So a diameter. So now label the point of intersection on the circle. Label them A, B. I don't know what you want to call the circle. I'm gonna call the circle O. But what you gotta do now is you're gonna construct. Okay, after you draw the diameter, you're gonna construct the perpendicular bisector once again for like the millionth time. Open more than halfway. That's more than halfway because this is the midpoint. So go like this. It's like drawing two more circles, but I'm not drawing the two circles because it's too much work. That's it. Points of intersection, this and this. So what am I gonna do? I'm gonna connect those points of intersection. Okay, so I did. So what did I do now? I just constructed my square. How? You're gonna connect this point of the bisector with this point B, okay, with this point, I don't know, point C, okay, with point A, let's call this point D, I don't care. Connect them. There you go, that's your square. Not bad, right? Okay then, that's all you had to do. The square is inscribed because it fits perfectly into the circle. Okay, now construct the tangent to the circle at a point shown. Sure. So this is the circle and this is the point shown. Okay, so what you're gonna do is you're gonna take, okay, the compass. Now first you're gonna extend a radius and beyond. Okay, that's what you're gonna do. And now with the compass, you're gonna measure. You need two other circles, so you're gonna measure the radius. Once you do the radius, go to the point on the circle and draw a circle like this, or just draw the mark, whichever is easier for you. And label this point, I don't know. First, we haven't even labeled the point. So A, let's call this B, and let's call this C. Okay? Now that you have done that, guess what? Now construct the perpendicular bisector of AC. Look. More than halfway. Okay? And then go to C, with the same length, of course, and do that. And that's it. That's all there is. That's all there is to it. Look, one time, tangent, one time to the circle, that's all it does. It touches it one time. Not twice, not none, but one time. Okay then, let's move on. This was tangent to, from point on the circle. Okay, and now this. It says, construct the two tangents to the circle that passes through the point P. Point P is right here. I don't know if you see it. That's point P right here. Okay then, so the first thing you're gonna do is you're gonna connect the center to point P. That's what you're gonna do. And then what? Construct the perpendicular bisector of point, let's call this A. Construct the perpendicular bisector. How many times? 3 million times perpendicular bisector, my God. Perpendicular bisector. You don't need to pause this. You already know what the perpendicular bisector is. Do that. This is different than the other one. When you only constructing one tangent from a point on the circle, it's different than when the point is outside. So now connect the intersection points. So that's not touching. Of course not. That's not the process. You're not done yet. Okay? Now go. Since you have the perpendicular bisector, now you know that this is the midpoint from A to this. Let's call this, let's call it B. From A to B. B is the midpoint of AP. So open the compass to the radius now of the new circle. You know what the radius of the new circle is? Done, right? I'll show you. So you're gonna construct now again. Look, open. Construct. Open the compass to the radius of AB. See that? AB is the same thing as AP. See that? Okay then. So now go to from here, and you're gonna construct a circle with center B. Okay? Now I'm gonna be honest with you. You didn't need the whole circle. All you need is this point and this point right here. Okay? What I wanted to show you is that BA is a radius of circle B. So BA is a radius. So anywhere you go here is going to be the same distance. See that? And guess what? The same goes for BP. The same distance from AB to BP. So that means that these points will also be equidistant from P. Okay? You want to label these points? I don't know. Call them DF or DE. ME, whatever you want to call them. But now look at this. You connect P with D and E. These are your tangent lines. Same distance here, same distance here. That's it. That's all there is to it. Okay then. So now you gotta solve these equations. I'm not gonna solve them for you. You have them on the previous lesson, so good luck. So the common denominator here is 15, so I'm going to multiply the whole thing by 15. Okay, so I multiply the whole thing by 15. So 15 divided by 5 is 3, times 2x is 6x. 15 divided by 3 is 5, times 1 is 5. 15 divided by 15 is 1, so then the top remains the same. Now, so fractions, like terms, variables on both sides, yes, so I'm going to get rid of the lesser one. I'm not going to do any more than that. Here, well, the common denominator is 6, as I can see, so I'm going to multiply the whole thing by 6. Alright, oh, I keep on closing the parentheses. I'm not closing the parentheses. I'm closing it right here because I'm multiplying the whole thing by 6. Okay, so let's multiply by 6. So 6 divided by 6 is 1. So that means that the top remains the same. 6 divided by 2 is 3. So I have to multiply everything by 3. So then that's plus 6x minus 24, because 3 times 8 is 24, equals to negative 24. Okay, so let me see now. Like terms, yes. So 7x, 7 minus 24 is what? Right, negative 17. And that equals to negative 24. I'm not gonna do any more than that. You're on your own. Thank you very much, and I hope you learned your lesson. Bye-bye.